we will be considering name reaction. Today, we will consider a very important reaction, that is Hoffmann Bromamide reaction. So, please get your pen and paper and let's begin. I am sharing my whiteboard. So, Hoffmann Bromamide reaction is a very, very important reaction. Why? Because it will involve the conversion of amide, okay, to primary amine. But most important tip in this is with one carbon less. So if you want to decrease the length of carbon chain, beginning with amide and converted into amine, this is a very, very typical or characteristic reaction. So let's see what is this Hoffmann Bromamide reaction. It involves, as you can see from the board, conversion of amide to amine with one carbon atom less. The reagent used is alkaline hypohalite solution, which is nothing but take NaOH plus Br2. See, instead of mugging out the reagent, we can just have a look at the names and try to recollect or write the reagent. So, hypohalite, as the name suggests, hypo will be your alkaline solution, that is either NaOH or sometimes examiner gives KOH. And halite is refers to halogen. Okay, so Br2 or Cl2. Sometimes in order to confuse you, the examiner can give KOH plus Cl2. Then we need to understand that it is actually Hoffmann Bromamide reaction. Let's see the reaction. You have amide, RC double bond, RC double bond O NH2 plus Br2 plus when we take 4 molecules of NaOH, and then what we get is amide, amine from amide, okay, and the side product is NaBr plus sodium carbonate. And 2 molecules of water will be formed. So, you are paying attention. Hence, it is conversion of amide to, not amide, but amide to amine. Okay. Now, what is the mechanism involved? In mechanism, we have NaOH plus Br2 will give you NaOBr. And you can write this Br2 as, in order to understand better, as Br like this. So, what we will be getting is we will be getting HBr as side product. Okay, and we are left with what is known as hypohalite, that is NaOBr. So let us see what is the mechanism. Now you have this amide. Okay, I can write this amide in this fashion also. One molecule H here, one molecule H here, and we attach NaOBr. Now what happens? Alkali has the ability to abstract a proton. Alkali will try to abstract a proton. Okay. So, in this case, obviously, the nitrogen has 3 bonds and lone pair is existing on that. Now, we will be getting RC double bond O, NH, Br. One molecule of nitrogen is born like this. Okay. And obviously, one lone pair is already there. Okay. So this is known as N-bromamide. Okay. The name is N-bromamide. Next step will be what? Again, N-bromamide is treated with OH. One more hydrogen is there. A proton is there. So you have this. This is formed. N-bromamide anion have a negative charge. This is known as N-bromamide anion. First step, one proton is gone. Second step, another proton is gone. And we end up with what is known as N-bromine. In the next step, again, this bromine is also lost. So we have RC double bond O. Okay, this is there. Again, this is lost. with a negative charge. This is then will react with, or this R will go to nitrogen to give you Rn. This will come here, C double bond, which is not Rn double bond C double bond O, which is nothing but your isocyanate. Isocyanate is then treated with your water. So if I am to write memory technique, then it will be H2O like this. To yield R N H2 plus CO2. So the CO2, the CO2 will easily react with NaOH that is present in the system to give you Na2CO3 plus water molecule. Okay. But an important aspect over here is when isocyanate is treated with. So the whatever is written in yellow is your memory technique in order to finalize or get the final product. So before this amine is formed, what actually happens is carbamic acid is formed. That means you have R N H C O H double bond. This is your carbamic acid, which will then rearrange like this and like this to form, to give you amine and CO2. Now CO2 will obviously react with NaOH to give you sodium carbonate. So this is your mechanism. Now the key highlights of this reaction is amide to amine conversion. The carbon with one carbon atom less, decrease in carbon chain length. Third most important is formation of isocyanate and carbamic acid as intermediate. So these are the key takeaways. If you want to understand the application of this particular reaction, then we will move on to next the applications. So is this reaction clear? You'll have two of this, then it is balanced. Okay.